Hello?
Hello?
Hey.
Hey, you should come over to our house and do this stats project. It's really fun, I promise.
Is it?
Yeah. You can have a time and go night.
Alright. I'll be there in a second, I guess.
Go.
See ya.
Bye.
Hey!
Hey kids, I am 95% confident that I'm going to learn you a knowledge about confidence intervals. And we use 95 because we weren't given a confidence.
So, for our stats project, we decided to talk about what true proportion of Union High School students prefer learning with the netbooks over pen and paper work. And so that's what we did.
I would hope so. Did we do it? Did you get the data? So, in order to have a reliable study when producing confidence intervals, you must meet 3 conditions that can be represented by the acronym BIN.
The B in BIN stands for bias, which can be avoided by making sure your data is of a simple random sample.
The I in BIN stands for independence. Now this states that your sample size cannot be more than 10% of the population that you're studying.
And the N stands for normality, which can be determined if you have 10 successes and 10 failures, given the probability of success of your data.
Do we meet bias?
Hey, Mr. Trigger, can we do this?
So basically what we asked Mr. Trigley if we could do was to interview 20 random students that we got by using a calculator to randomly generate the numbers and basing it off of the total number of students at Union High School. But he wasn't very fond of us kicking kids out of class to interview them, so we couldn't really have a simple random sample like we wanted to initially.
So, despite our tragic rejection, we still had to do our project, but with a much less randomized sampling method. Instead of using a simple random sample like we wanted to, we had to go out at lunch and ask kids directly and survey them of their opinions.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 272, 273, 270.
Now, this was much less randomized because we actually chose the kids to choose, but we chose them at random. But not everyone will believe that, so our study is much less reliable.
So proceed with caution.
What about independence?
Independence! Yes. We know we have independence because our sample size meets the 10% condition, which basically means that our sample size is less than 10% of the actual population. So, given that the population is 1,689 students, and our sample size was 22, it's less than 10%. We're independent. Because we're in America. Normality.
Don't you mean normally?
What?
It's properly pronounced normally, and it can be determined by at least 10 expected successes and 10 expected failures. And since our data's NP and NQ are both greater than or equal to 10, we can infer that our data is approximately normal.
Aside from using the success and failure condition to determine normality, you can also use central limit theorem, which basically states that if your sample size is from 25 to 30, then basically you can...
So what the central limit theorem actually states is that with a large enough sample size, your sampling distribution will be approximately normal. But never, ever, ever, ever say 25 to 30. Just know it in your head, but never say it, because if you do, you fool.
That's wrong. You just lost points.
You dumb.
Since all of our conditions are approximately met, we can actually complete our data now.
And we did.
It's right there. results from our survey, where we asked people whether they preferred learning with the netbooks over traditional pen and paper work, we found that 10 people preferred learning with the netbooks, whereas 12 people preferred learning with traditional work.
But what can we do with this data?
I don't know. We have to consult the stats wizard.
Audio Jungle.
I was 95% confident that the prophecy foretold your arrival.
Oh, great stats wizard. We have data, but we don't know what to do with it. Please, help us in our time of need.
Yes. Touch upon the ball of stats and gain knowledge of confidence intervals. Peace, bro.
From the results of our survey, we can create what we call a confidence interval, which basically gives us a range of numbers to which the true proportion of Union High School students who prefer learning with the netbooks falls within.
When calculating your confidence interval, your final answer will be broken down into two parts, which is the statistic and the margin of error. It can be written out in formula form as statistic plus or minus z star times the standard error, and the standard error times the z star, which we'll explain later, is your margin of error.
Standard error within our equation can be solved by taking the square root of the product of PQ divided by N, with P being the probability of success, Q being the probability of failure, and N being the sample size.
So, the other part of a confidence interval's margin of error is the z statistic, also known as z star. And to find z star, we can use our handy dandy z chart. So, using our handy dandy z table, we can find our z-star value using our 95% confidence value. Now, because we want to be confident in the majority of our normal, approximately normal distribution, we need an equal amount of data to be on each side of the distribution. So this tail must be equal to what's left on this side of the tail. So, because we're using 95%, that means there is 5% left between that and 100% confidence. So that means we need 2.5 to be on this side and 2.5% to be on this side. So, 95 plus 2.5% is 97.5. So, we come to our table and find that 97.5% is right here. We move to the left, find that that is 1.9 standard deviations above the mean, and move up, and also say that is 0.06 above standard deviations above the mean. So you add those to get a z-star value of 1.96.
It's pretty good.
An easier way to do this is to use your t-table, however it only works with common confidence values. If you'll come here, you see here's 95%. If you move all the way down to this tan column here that says z-star, depending on whatever confidence value is up here, 50, 60, 70, 80, 90, 95, it will give you the z-star value right here. And as you can see, as we just found, 95% comes down to 1.960. So now that we know our z-star value is 1.96, we want to find the two other portions of our confidence interval, the statistic, p-hat, or the theoretical mean, and the standard error of p-hat. To find the statistic, you want to take the number of people that were a success in your study. In our case, there was 10, and you want to divide it by your total sample size. So that gives you a p-hat of 0.45. And I'll just always, in stats, always write to 4 decimal places and then just stop. Now, to find your standard error, you want to use the formula square root of p-hat times q-hat over your sample size. So, we just discovered that p-hat is 0.4545. So that means q-hat is going to be the probability of failure, which is going to be 1 minus that. So, surprisingly, q-hat is 0.5454. So now, you multiply those two, divide it by your sample size, for us it was 22, and then square root it. So therefore your standard error is 0.106. Now you have all your numbers to calculate your confidence interval. To do this now, you must find your margin of error, which is simply your standard error times z-star. So therefore, your margin of error is 0.208.
Now that we've solved for the margin of error, we can use this data to solve for the confidence interval.
Courtesy of the stats wizard.
Thanks, Mr. Munoz.
Yeah. Now, we will both subtract this and add it to our mean of 0.4545. I have gone ahead and stored this in the variable x, so I don't have to type it out every time I want to do something with my life. So, therefore, we find out that the lower boundaries of the lower bound of our interval is 0.246. 2.2465 to be exact, or just better rounded. And now we will add it. So our upper bound is 0.6626.
So, with our interval complete, we can successfully state that we are 95% confident that the true proportion of Union High School students who prefer learning with the netbooks over traditional pen and paper is between 25% and 66%.
And it is a very wide interval, but this is only because of a small sample size. When you're doing a study of your own, you should always shoot for a larger sample size, but remember it's still less than 10% of the population. So this has been our project on statistics confidence intervals. We hope that you have learned about finding an interval to represent the true proportion of your population that you're studying. But you may ask, why did we do this?
For a grade?
I'm 95% confident that we did it for a grade, so.
Confidence intervals. Thank you for watching.